Right, good afternoon everyone. Welcome back to the conference. So this is the workshop 2 about excess water challenges. Okay, so welcome all of you. And you can see on your left hand side there's some coffee and tea, so help yourself. And it's a workshop, so it's a classroom, so we try to learn from each other. So it's not a very formal type of presentation, things like that. So we try to interact with all of you here. Okay, so as I said, this is a workshop about excess water challenges. So I just want to go through with you what will happen in this afternoon and also tomorrow morning. Okay, so this is the timetable, or actually the agenda for today. So we try to split the workshop into 2 parts for today. So the first 2 presentations are mainly talking about something from the sky. Okay, so climate change is talking about how the environment change. So that would be talking about excess or extreme precipitation and also some sort of typhoon stuff. So we try to understand what happens from the sky first. So after the break, we will have another 2 presentations to talk about what we receive on the ground. Okay, so it's talking about landslides and also flooding. Okay, so that's the design for today. So closer to the end of the workshop today, we have a panel discussion. We will invite the speakers sitting at the front so that we can have some discussion on the presentation for today. Okay, similar idea for tomorrow, and we have many international experts talking about mainly focusing on the engineering technologies, the latest technologies that we try to adapt climate change on our urban built environment. Okay, so I'm not going to repeat that. I will introduce tomorrow morning. So it's just to promote it, and hopefully you can return tomorrow morning on Sunday. Okay, so that's our plan. As I said, it's a very informal, it's a discussion workshop. We try to generate idea. So feel free to chip in any questions. Okay, so is there any questions? Happy? Everyone understand what we are going to do? Yeah, good. So without further ado, so I will introduce the first speaker for today, Professor Carlos Lima. Okay, so he is a professor in Department of Civil and Environmental Engineering in the University of Brasilia in Brazil. Okay, so he has an expertise in hydrology, hydroclimate, stochastic modeling, and also machine deep learning models, and multi-scale hydroclimate analysis. So he is also experienced in working on large-scale climate oscillation and also the development of climate-informed models for reservoir inflows, floods, droughts, and rainfall. So may I leave you for the rest of the time?
That's okay.
Can you hear me? Probably not need to use the mic. Okay, I think it's better. So, thank you, Anthony, and good afternoon, everyone. So, it's a pleasure to start this workshop talking about the rainfall. And when you think about the biggest natural hazards in many countries, they are like floods and landslides, droughts, and in the end they are all triggered by rainfall, either excess of rainfall or lack of rainfall. So I'll try to give like a general overview about climate change and extreme rainfall. Maybe something here is not new for you guys, you probably know, so because I don't know your background, but excuse me if it's something not new for you. And in the end, I will try just to show some application and what I have done in the last years about in terms of modeling, basically. Okay. Let's go here. I'll just start showing you some events, flood events and landslides events in Brazil. So they were very important for us, so that we are aware about climate change and the biggest impacts. Here it was in Rio de Janeiro, in the mountain region of Rio de Janeiro state, 2011. We have several landslide events, and here it's interesting is the rainfall. It ranges from 100 millimeter to to 500 millimeters in one day, maybe less than one day, 3 hours or 4 hours. So the intensity was like huge, huge. This is supposed to rain in 6 months, so basically have a big event. And yes, the impact, we have almost 1,000 deaths, missing people, and over 35,000 people that was displaced. And then in 2011, we had another interesting event. I went to this place here, was in South Brazil. We have a landslide event. Here is just to show you the size of the rocks that rolled down, I mean, during the event. So it basically changed all the landscape here in this region. So, and the thing is, we had no rainfall data. We don't know the rainfall. We have no information about deaths, missing people, no data. And the interesting thing here is when you look at the return period of this event, it's possibly thousands of years. I mean, the geologic event, because it changed like here everything. But we cannot link with the rainfall event. We don't know if it was like a 100-year rainfall event or 1,000-year. There is some connection that we still don't know. So, and this is very important if we think about modeling this kind of events here, the probability of this event. We need to understand, to better understand this kind of connections. And this is another event in South Brazil, in the Santa Catarina state. It's a flood event. So in 2008 flooded about 4 or 5 cities. So we suffered a lot from this event. We don't have so many data. That's another issue, because that's one of the, I would say, adaptation measures. First is monitoring. We need to know the rainfall. And in some places of my country, I mean, even the rainfall data, you have no idea. And it's hard to model and think about adaptation measures when even the rainfall, you have no idea where it rains, the amount, the intensity, the spatial distribution, and so on. So here I just want to point this event. I think the next talk we'll talk about, the next speaker will talk about hurricane. So has a huge impact also here in the US. We are lucky, at least for now, we don't have many hurricanes in Brazil. We had one, 2004, was probably the first one that hits Brazil. It was actually was an extratropical cyclone that changed to a hurricane, but hopefully in the future we won't see this event. So we already have so many problems. And then we have some questions when you look at these events. It comes up, especially for us, for engineers and scientists, is how well we understand this climate risk for a given event and location. And one big question is whether this risk is still stationary, so we can look at the past and apply the tools that we have and look for the future, or it's completely no stationary. And if it's not stationary, what's causing its change? And one of the biggest thing is, can we predict it, these climate risks, at different time scales? So can we predict for tomorrow? Can be like, you can think about risk as probability of some excess of stream flow or rainfall. So can we predict for the next day or for the next week? Or some statistics for the next century. When you think about climate change, are we interested in the next decades or the next century? Can we somehow predict this risk? And another interesting thing is we can think about floods or droughts. Let's say we have like experienced a big flood this year. What's the chance that this flood will happen again next year? So we are thinking about the risk if it's stationary or not, or if it's independent or not. Like here, that was hit by a very large hurricane last month. So what's the chance that next year another big hurricane will hit Hong Kong? So that's the kind of question people keep asking, like also for droughts. As I told in the morning, we have experienced a big drought in Northeast Brazil, and one of the main questions that stakeholders, people who work with um, urban water supply. They ask is, so next year, are we going to have another drought? Because this year, last year, we had this drought. So what's the probability to have another drought next year? So this is some concepts we try to explore. And also, how will climate change impact the long-term climate risk? Because I will try to show you for you guys here that this risk, it operates at different scales. You have like a monthly scale, daily, and interannual scale, decadal scale. How do you can combine all these scales and also look at the long-term risk that is caused by climate change? So I'll try to, I don't have answer for all these questions. I'll try to show some answers here. And I have a lot of slides, so hope you don't mind if I'm too fast in some of them, but in the end we have some time, and if you have some questions, I'll be happy to answer. So here is the agenda of my talk. This picture is from IPCC, so it links the Earth and human systems. And what I'm going to try to address here is especially precipitation change, temperature change, and some extreme events. I will try to link with the drivers here, especially the greenhouse gases, and also with impacts and vulnerability, and also here with the socioeconomic development, how we can try to have some adaptation measures. That's not easy. We have discussed that a lot. It was very interesting, the morning session. So I'll try to focus on these, some of these issues, and particularly here on water resources. Here, we start with temperature. There is this increasing trend. This picture is very famous. It's from 1880 until 2017. So based on land and ocean data, if you look at ocean data, we see the same trend here, particularly after the 60s. So this is data. It's hard to say, no, there is no trend in the temperature. This is data. We have some uncertainty because this is global data, so we change the stations, the way we measure temperature, but more or less it's what's happening. So there is, I mean, we cannot fight with data. This is data, this is some facts. And the thing is what's causing it, so there is some discussion, but based on the IPCC, if you look at the forcing here from this recent period, most of the observed warming is due to the greenhouse gases. We have this anthropogenic effect. Here, all the anthropogenic force is basically the aerosols. So we have this negative effect, basically some cooling. And when we combine the two, here we have basically, it's saying that based on model data, it's like the greenhouse gas that is causing this warming. And another interesting picture that I like to show my students, also from the APCC. So you can only, based on this, on the models, GCM, global circulation models, you can only reproduce this temperature trend. Here is the black lines, the observed trend, when we include the natural and human forcing here. When we think about only the natural forcing, like solar radiation, basically using these models, we cannot reproduce the trends in the temperature. So this is another point saying, okay, this is the greenhouse gases that most likely are causing this, the observed warming there. And the thing is how we can link the increase in temperature with change in extreme rainfall events. And one of the arguments is related to the Clapeyron equation that basically says you have this curve here and you have temperature, and here is the saturation water vapor. It says as you increase the temperature, you increase the saturation vapor pressure in the atmosphere. So in other words, the atmosphere can hold more water vapor. So as we increase the temperature, you expect that you can hold, the atmosphere will hold more water vapor. So, and then it translates when, and this is some fact, and then when you look at the data, the water vapor column here, you see the red one is like just the trend. We see these trends in the water vapor in the atmosphere. Globally, we have more water vapor in the atmosphere in accordance with the Clapeyron equation. So And if you have more water vapor in the atmosphere, what it means? That you are increasing the evaporation. So places that are dry, usually dry, like the subtropical regions, they are becoming drier because you have more water evaporation. So you have more water vapor in the atmosphere. It is transported across the atmosphere, basically from the subtropics to the tropical regions and to the temperate regions. And then you expect more extreme rainfall events because you have more water vapor in the atmosphere. And that's tough to measure, but this is also data from the IPCC. We can see that globally there is some trend in the very wet days, especially in all this region here, in the temperate, like in Europe, Asia, the US. In these regions here, we cannot see. In South Brazil, there is some trend, but most probably it's not related to climate change. And another place we don't have data. That's the point. Okay. Especially, I talked in the morning about the Amazon. So one problem is we have no data, or just a few data, rainfall data. So basically, we don't know what's going on. Okay. But generally, we have experienced these extreme events. And if I want to show, I just want to show you some things here about Brazil. Here's just some pictures. It's a nice place. Here is the capital. So if you've never been there, I invite you to come there. We have good things to see. And here's some data about natural hazards. I'm sorry, it's in Portuguese, but I can show you. In terms of affected people for this period from, I think it's from the last 2 decades, we can see that in terms of affected people, number one is drought. Okay, number two, floods. We have 2 types of floods. We have human floods and river floods. So both have a huge impact in terms of affected people. And then wind, hail, and landslides is just here. In terms of affected people. But in terms of deaths, here affected, I mean displaced. Usually people that are displaced, they lose their houses and so on. But in terms of deaths, number one, floods, also human and river floods. Number 2, landslides. So this is a big issue in my country. And the trend is, when you look at, for these 2 decades here, in terms of natural hazards, it includes all these ones that I just showed it to you. We see an increasing trend. And when you look at floods, we see also in terms of number of events, we also can see this increasing in the terms of floods. And also landslides, we see the same numbers. So the number of floods and landslides is increasing in the country. That's too bad. Okay? And also the exposure. Not only the number of events, but also the exposure. So you have more people, the cities are growing, people will set in areas that are not appropriated, and so on. So what we can say about future global climate change? That's, I mean, the biggest picture. In terms of emissions, we have different scenarios. Probably you all know these scenarios. Will depend on our economic, political choices. Okay, we have different scenarios of CO2 emissions. We don't know which path will follow. I mean, depends on a lot of things. So, but we have different scenarios. In terms of temperature, here is the range. This number here, it's not likely that we have just 0.5. Most likely it will be somewhere here between 1 and 4 degrees Celsius. 1.5, as somebody said in the morning, it's very unlikely. I also think that's not likely here by the end of the century. So global sea level rise, also mentioned here. So I just want to show you, we have this expectation from 0.2 to almost 1 meters. That is from the last IPCC reports. Okay. In terms of temperature, I just showed you. In terms of rainfall, what we expect globally is the places that have high evaporation rate, like the subtropical regions, you have more evaporation. So places like Northeast Brazil, we suffer with droughts. So droughts will become more frequent, more intense. Places that rains a lot, like the tropical regions, including here, Asia, Amazon, some places in Africa, will rain more because you have more water vapor. Also, some temperate regions here, I mean, that's the general picture. We expect more rainfall, including not only in terms of the average rainfall, but also extreme events. I think I will show you in the next slide. Here is almost the same picture. We have just, but this is for the short-term rainfall for the next the 15 years, basically, 20 years. Here is precipitation minus evaporation, just showing what I just said, okay? In the tropical region, you have more rainfall, you expect more rainfall. In the subtropical region, more evaporation. And in some temperate region, you also expect more rainfall. So that's the general view. Okay. In terms of extreme events, I will just try to be fast here, but we also are expecting more extreme events. Even in some places that you may expect a reduction in the average rainfall, you can also have more extreme events. In our mind, it sounds like, oh, it doesn't make sense, but it may happen. You have decreasing rainfall, but the extremes, you have more extreme events, even though the average rainfall is decreasing. Okay, so what are the impacts that we might project? Here I just took this from the IPCC. I think the main message is climate change will amplify existing risks. Okay, and we're gonna see also new risks, and who will probably suffer more are disadvantaged people and poor countries. You see that the distribution of this risk is like unevenly distributed. So if you look at within and across countries, so that's a big problem. I just mentioned, like in the morning, that we are in a very difficult situation because we are exposed. We have low capacity of adaptation, so our risk is very, very high. In terms of drivers, we just mentioned here extreme precipitation, cyclones, extratropical cyclones, but mainly tropical cyclones, hurricanes, typhoons, and so on, flooding and storm surge. The general view for Central and South America, and also I took this from the IPCC and Asia, is what we just mentioned. Reduction in water availability, so we may face more crisis in terms of human water supply. Also increasing floods, landslides. We have already seen the numbers here in the last 2 decades. The numbers are increasing. In Asia, we have basically the same things. When you think about like these biggest events, but we have other impacts in terms of food production, energy, diseases. So, and in terms of hurricanes, I just want to show you just 2 slides here because I think it's important, especially in the moment. These are 3 recent papers that we see that we expect. It's hard to predict the future. What's going to happen in terms of hurricanes, because hurricanes are very complex. What we say is, at least for the main ingredient for the cake, in the case cake is the hurricanes, that's sea surface temperature. So they are increasing. So at least the main ingredient for the hurricanes, you have more now. How it will behave in the future, because you need the other things like the wind shear. So you have other things, but at least the main ingredient you have for the future that are high surface temperatures. And some papers show that you might experience higher rainfall. You have the same radius of the hurricane, you might experience high rainfall. And these two also they are also very interesting, because one shows that this is very I think this guy he published 2 or 3 months ago in Nature. You see that there is a slowdown in the translation speed that once the hurricane hits the land. And this is too bad, because then it stays more time there, you get more rainfall, because it stays more time in the land. And also this paper from the famous CARe guy from MIT, showing that it to be probably more difficult to predict hurricane as it gets more intense just before it reaches the land. So it's another big issue. Some other effects, I mean there are a lot, but I'll just mention some. So millions of people exposed to increased coastal flooding, that was mentioned, sea level rise increasing. So morbidity and mortality from floods, just mentioned. Diseases, vectors, especially when you have people that are very vulnerable. Okay, you have floods and you have a lot of mosquitoes that spread in these areas. So this is a big issue. Also in agriculture, in supply chain, companies that have can have some disruptions due to floods and pollution of water bodies. We can list a lot of impacts. I mean, just mention some of them. So, in terms of adaptation, that's also an interesting talk, but very hard. I like to show this kind of management, flood risk or risk management cycle. We can act in all aspects of this cycle here, so that we can improve our resilience. We can take some adaptation measures. For instance, in prevention and mitigation, hazard prediction and modeling. We need to at least to predict what's the probability of that event, the hazard, okay? Also, the vulnerability management. Who are more vulnerable? What are the vulnerable areas? This is not easy, but we can tackle, I mean, this topic here. Also, preparedness. This is also another interesting point, especially in my country, because that's fine. You can predict the rainfall for the next hours. Okay, you predict a very extreme event of rainfall or flood. So what do you do? And in Rio de Janeiro, for instance, that event that I showed in the first slide, there are some conflicting predictions. One center predicted extreme rainfall in the next hours. The other center, climate center, predicted nothing. And I mean, the civil defense had they didn't know what to do. Because even if you predicted an extreme event, what do you do? Okay, you need to alert people, but how? So you need also to open this preparedness. And then the alert system, early warning system, public warning, what you do, how you tell people, what these people do, they move to where, and this is hard. And then the response once the event happens, what you do, recovery, and this is also important here, post-disaster. After it happens, what can we do? And one problem we face here is like the memory. Okay, like if in the short term you have high memory of what happens, and then you can take some measures. But after a while, especially in my country, after like 1 year, you just forget what happens, and that's it. So you do nothing. You just wait for the next event, and that's not good. Okay, so, and then this is tied to how we define risk, and there are different approaches. I just take this from the IPCC. Basically, it's the product of hazard, the probability of that event to happen, and then exposure, and then vulnerability. So we basically can focus on all these three entities here to compose the risk. Okay, this is just one approach to more technically define the risk. And we have some adaptation measures. This is you can go to the IPCC reports. They show a lot of measures. I just mentioned some of them, especially when you think about floods. So structural measures, you can build infrastructure. This is another point that we were discussing in the morning. But if you go to some countries, especially in South America, Central America, we have no infrastructure. We cannot think about future if now the present time we have nothing. We have no dikes, we have no protection, even sanitation systems. It's like terrible. If you go to some cities, no urban drainage systems. So we still need to build some basic infrastructure before we think also about the future. This is also an issue. And then on structural measures, here I would like to point out the importance of monitoring rainfall, monitoring stream flow. and also develop some early warning system. And this is tied to forecast, like short-term forecasts, long-term forecasts, okay, that we can improve. And also, we need to better understand of the climate system. We need data. I heard some talk, I think it was last year, and one of the guys said, okay, no, we don't need more data because we can model everything. I said, wow, how we can model if we don't have data, if we don't understand the system? And in some places there is a trend, okay, you say you don't need to monitor anymore. You don't need to have rainfall station, rainfall gauges, because we already know the system. And I think we are a little bit far from this understanding how these things work. And then there are some other measures here. I will just skip them because they are known. Okay, I think this slide I will just skip one. Some of the key issues, this is more technical. I would say first one is lack of data, especially rainfall and stream flow data. For some places, not only in Brazil, even if you go to the US, you don't have data and you cannot understand the dynamics, especially when you talk about rainfall, because there is some not only temporal but spatial patterns, spatial variability that we need to better understand, and with no data, no understanding. Other issues about the global circulation modes, if you look at the future, we have at maximum daily scale. If you think about rainfall, we don't have like a sub-daily scale. Oh, okay, thank you. So, but when you think, for instance, I will show you here some papers about the intensity, duration, frequency curves. Think about drainage system, you need this kind of information, and this is about sub-daily scale, and we cannot get this from GCMs, okay? Temporal scale, also spatial, that's the well-known downscaling thing. Relation of rainfall and the event, as I mentioned. So we have some connection with rainfall and stream flow, landslide. How is this connection? When you think about return periods, do we really understand? Because as I said, maybe it's a non-linear process. We have just a small increase in the rainfall, but to have a very, very, very big increase in the flood or the landslide. So also, robustness of public institutions. This is another thing, another issue. It's not related to the technical side, but we need also strong institutions to manage the risk, and qualified people. And also the other point I mentioned is like financial. If you don't have like your resources, it's hard to talk about adaptation when you don't have enough resources. So just to finish here, I'll just show some applications and some projects. I have some list here, but I will not read. I'll just show you what some papers. Here we published some years ago. We think about the flood risk not stationary. Okay, we think that it will change. It changes along the years, and it depends on the climate system, on the state of the climate system. And we try to link this risk with the state of the climate system, so that we can have some early warning system. So we say, okay, this is like the probability of flood. Let's say the 0.1. It's not that hard. This is the stationary approach. But then we say, okay, for some years, depending, in this case, we use that's for the Manaus city in the Amazon. We use some information about the El Nino, and say, okay, if you have like La Nina event, the risk of flood is much higher. When you have El Nino events, the risk of floods are very low. So, and then in the beginning of the year, we can issue this early warning system and say, okay, there is a high chance. The chance of flood is not 0.1, it's much higher because we have some La Nina event, or the river stage is already high. So we have kind of early warning system. And this was another paper. It's also related to this, what we call hydroclimatology of floods. We try to better understand we say that each flood is one unique event, and it's driven by some climate factors, so that we try to understand what's going on. And here we use a machine learning approach to classify the floods in here is southeast Brazil, to classify in 4 different patterns. And then we look at what's happen? We have four different types of floods. What happens in terms of atmospheric circulation, the scaling process of the floods, the magnitude of the floods, how they are interconnected. Here we have many stream flow gates, how these floods they connect to each other, so that we can better prepare for these events. And if you think about some warning system, we have more information. And this is a paper from some colleagues who have worked. It's like we have, as I told you, this risk operate at different scales, how we can combine all these scales. Because when you look at like future climate projections, maybe you have some decadal variability that's not captured by these models. Okay, that's the thing. When you look, because it's very nice when you talk about climate models, they are nice, they have very useful information, but you also need to make sure that they can at least reproduce some cycles that in some series we can observe what we call low frequency or decadal variability. And here is just some way using what we call a wavelet autoregressive models that we try to combine all the cycles. You can use like long-term trends, you have decadal variability, and then we try to incorporate all these for future simulation of potential scenarios. It can be of daily stream flow, daily rainfall. Okay, here is another one, but I'll just skip this slide. And here we just published this work, was this year. We try to access how climate change will impact the intensive duration frequency curves. This is for Korea. Okay, use some Bayesian model. I will not go into the details, but I'll be happy to answer if you have some question. And it's interesting because we have a regional model, and what we observed, we have these two curves here. It shows the future, I would say the average rainfall and the variance of this rainfall for two scenarios. 6.5 is the blue curve, and 8 is the red curve. And what we observed is there will be a change in the average rainfall. The black curve is the historical, okay, the historical curve, so it will increase the rainfall. Between the two scenarios, not that much, basically the same thing. But when you look at the variability, is what we observe is both scenarios will increase the variability, so you have more extreme events, okay? But scenario 8, you have more variance. So you are more expecting more extreme rainfalls due to changing the variance. Not that much in terms of the average, but in terms of the variance. So you have more extreme events. And then we built these IDF curves. They are very interesting, and to see this change. And what we observed, that's the historical and scenarios, is a significant change in short duration and extreme events. This is the return period. This is 100 years. We observe this, I mean, the bigger change in the less frequent events. Okay, this is another application. It's about radar data. So in many places of Brazil, we have this radar data about rainfall, but we don't use it. The question is, how can we take this data and use? And one possibility is to predict stream flow in some basins. So we are trying to do this. And another thing is about landslides. I'm trying to start some project with geotechnical people from my university to see how, if you can have some alert system, we can predict the rainfall, and if you understand the triggering points of the rainfall, if we predict the rainfall, and then the geotechnical people can predict the impact of these landslides. And this is very important, especially because these highways, they are operated by private companies, and they need this information. I mean, it's very important for them. Okay, here's just the same picture. Here's the group that I'm trying to operate. Here is just another work about landslides. This lady, she was from my university. She was just trying to estimate the probability of a landslide event given the rainfall. Okay, I'm just finished, almost 1 minute. Okay, and finally, this is some ongoing project. It's very recent. We are trying to use these deep learning methods that work with big data to predict here's the satellite rainfall data. Here's South Korea, I think we are somewhere here. So here we have this data. We are basically trying to predict the next day, next few days satellite rainfall data using this kind of fancy method, deep learning methods. Here it's just the observed rainfall. Here's the prediction. It's not that good so far, but hopefully in the next day we'll improve. Okay. So final remarks to finish. I think the most important point is global warming will change the risk, and most vulnerable societies is like poor people, and this is a global problem, as I showed. It's not something like, if we just think about our countries or our society, it's gonna be very, very, very hard. So we need to think as a global problem, see how other countries, I mean, what are their problems, how we can interact and help them. So I'll just stop here because of the time. Sorry. So thank you.
Thank you, Professor Lima, for his very informative presentation. I trust you have lots of questions, Professor, but shall we have another presentation from Dr. Lee from HKO? After this presentation, we will have a short Q&A, so you can ask questions to the two speakers at the same time. Okay, thank you very much. So, Dr. Lee, he's Senior Scientific Officer in Hong Kong Observatory. So he has been involved in a lot of projects relating to weather forecasting and also something about typhoons, so tropical cyclone research. So we have heard a lot of rainfall from previous presentation, and Dr. Lee will talk about a little bit more about rainfall, but also about typhoon. Okay, Dr. Lee, please.
Thank you. First of all, thank you very much for inviting me to have this talk. This section is about water, so extreme rainfall and tropical cyclones are two most favorable weather event in Hong Kong people. They all the time want to have the bad rainstorm warning and cyclone number 10, tropical cyclone warning. This is what they wish. But this year, they really got the cyclone number 10, but they don't want to have it again. This talk, I will go through the past trend and the future projections of extreme rainfalls, as well as tropical cyclones. It is a quite complicated topic, but I try to make it very short, okay? Within say, 25 minutes. First of all, it is the extreme rainfall events in Hong Kong. We will go through something happen far, far beyond your era and to what will happen in the next century. This is the observations from the Hong Kong Observatory. We start our business in 1883. This is more than 130 years ago. So we have the hourly rainfall of Hong Kong for over 130 years. So we see everything happen in Hong Kong in the past 100 years. That will help our engineering departments to prepare such excellent infrastructure in Hong Kong. From this one, you can see the annual rainfall change quite dramatically from year to another year, and with very significant decadal variations. But overall, we can see the trend of the rainfall is increasing slightly from about, say, overall trends about 20 millimeters per decade, and in the last few decades is increasing to 40 millimeters. But 40 millimeters is very small, right, when compared with the tropical rainfall in Hong Kong. So it's supposed to be not that serious. But if we look at the rainfall day, the number of days we have rainfall, if we have a more increasing rainfall, we're supposed to have more rainfall day. But in Hong Kong, we see a quite clear decreasing trend of the rainfall day. The problem is coming up is that we have more rainfall, but we have less rainfall day. So from a primary school student, you will know that every day it rains heavier. And is it the case? Yes. From the last few decades, we can see that there are more and more days with 30 millimeter per hour rainfall. That is the amber rainstorm signal in Hong Kong. This is one of the signal system in Hong Kong. Amber is the first stage of the warning. I will show you. Then is it red and black. Red, everybody will, yes, bad rainstorm. Okay, because the school closed, nobody go to work, so they feel it's exciting. But you can see that there's an increasing trend. And more importantly is the extreme part, the record of the heavy rain, the hourly rainfall. Since we started business at 1883, the first highest rainfall record occurred in 1886 is 88 0.4 millimeters. And then it takes, for example, 3 to 4 decades to have another record. It's 1926. It goes to 100 millimeters per hour. Okay? And then another 3 to 4 decades, another new record, 108 millimeters per hour. This is already very high, I can tell you. For rainfall event with over 100 millimeters per hour, you don't really want to stand in the street. Okay? No matter what you bring, what you wear, you get wet anyway. And then after 1990s, the situation a little bit changed. You see that it just took 20 years to have another new record of 109 millimeters. And then a few years later, 115 millimeters. And then 2 years later, 145 millimeters per hour. That is really huge. Luckily, that line temporarily flattened in the last few years. We hope it lasts for next century, okay? But we cannot ensure that it won't go up again. But 145 is already very disastrous. I think my engineering department's friends can tell you how disastrous later. Okay. So you see the frequency of breaking of extreme rainfall is increasing. Actually, from a more statistical perspective, we can see the chance of this heavy rain or extreme rainfall in Hong Kong to occur. The lower bar here, you can see that this is the early 20th century probability of having rainfall over 100 millimeters, and 2 hours over 150 millimeters. And in the last 20 years, it's increased significantly, but nearly double the frequency. And if we use the time-dependent GEV to calculate it, it's nearly half the return period is already half by, say, from 100 years to 50 years. Okay. So this is the case that we see a more extreme rainfall in the past. And some heavy rain in Hong Kong, actually in the past, we learned from the past, we can see that the heavy rain in Hong Kong are usually triggered by several major weather systems, the tropical cyclones, the southwest monsoon, and the prolonged effect of the trough or low pressure that will bring heavy rain in Hong Kong. And all these are the heaviest rain record that we received so far from 1 hour to 7 days. And these are generally based on several events. The one in 2008, I will show you. And also 2 events before the World War II. One is 1818 line, and one is 1926. The rain are really very heavy. With over, for example, 12-hour rainfall can up to over 500 millimeters per day. So this is very, very heavy rain. For example, in August, the monthly rainfall actually 300 something. And you have one day with 500 millimeters. This is already really difficult to bear. And for example, the 1926 rainstorm, it was triggered by a tropical cyclone making landfall to the east of Hong Kong. When it moved to the north of Hong Kong, it curved back to Hong Kong, to the north of Hong Kong. And the southwesterlies associated with the tropical cyclone bring very, very heavy rain to Hong Kong. At the time, the heaviest areas is over Hong Island and Kowloon and flooding every area. And this is the Happy Valley. So Happy Valley. So the horse races, of course, was all flooded, and also the central part of Hong Kong. And the rainfall, actually, hour by hour analysis, you can see that is quite heavy. This is one of the typical cases of extreme rainfall in Hong Kong. I draw 3 lines. This is the yellow line, this is amber line, and the red line is red line and the black line that refer to the rainfall threshold of the warnings in Hong Kong. The amber is the first warning, the red is the second, the black is the highest. So if we have the hourly rainfall over 70 millimeters per hour, it's already up to the black rainstorm level. So you can see that the rainstorm carried over about 12 hours, and with many hours with the hourly rainfall over up to the red and black rainstorm criteria. So it's totally quite heavy on that day. And remember, before the World War II, the infrastructure of Hong Kong is completely different from nowadays. So you see how disastrous at that time of the year. And after the World War II, we still have quite a lot of significant weather events that cause heavy rains in Hong Kong, and some of them are still very memorable, and many people still remember them, especially our engineering department colleagues, including the rainstorm in 66, 72, and the one in 208. First of all, the 1966 rainstorm is very phenomenal, and the rain is so heavy that you see that all the car on the street of this street was pulled down by a fresh flood to here, pile up everywhere here. This is one of the most dramatic pictures, and this is how it look like if you have Leighton Road flooding like that. Okay. So thanks to our infrastructure design, it's much more better nowadays. And for the 1972, it's very sad that two very serious landslides that killed over 150 people, and one's in the Kowloon area in Summer Pink, and the other one is Posan Road near the Hong Kong University. The landslide even pulled down one of the buildings. So this is caused very significant casualties in that year. And after that year, we start to have the GEO to manage the landslopes in Hong Kong. And the 2008 is the year that we have 145 millimeters of rainfall. That was very heavy, and the most heaviest area is over Lantau Island, and the whole, this is the, if you come from overseas, you will have this, using this North Lantau Highway to come to Hong Kong, over to Kowloon area, and all that was flood, and the airport was really close at that time. So this is very difficult to handle. And also, as mentioned today by our colleagues in GEO, the lateral slope landslides is very, very serious. Okay, many lateral slopes going down and cause block quite a lot of the roads, and block some of the places become landlocked for a few days. So what will happen if we have the climate change? Climate change, as mentioned by our previous speaker, that we have the Clausius-Cabriones relationship. If we have a warmer atmosphere, every degree increase in the atmospheric temperature, it will, as usual, about 7% increase in the moisture capacity. So very easy thinking that every degree increase is likely about 7% rainfall. But this is only the average. Some recent studies also explore the possibility of extreme cases to increase in the rainfall due to this kind of the increase in the moisture content can go beyond, we call this CC relationship, become a super CC relationship that can up to 14% in per degree increase. So the extreme will become even more extreme at that cases. And so also the increase in the moisture capacity will change the rainfall pattern. You have a bucket of this size. If you have a bigger bucket, it's hard to fill up all the water. But once it fills up, it pulls down, the rain will become much more heavy. So it will also decrease the rainfall day. But every day you have rainfall, it will be much heavier. So here says that it will be harder to rain, but if it rains, it pours. This is the case. Quite recently, in the last few decades, I think we experienced quite a lot of these cases in Hong Kong. This is also the picture that depicts how the warm ocean will create more rainfall. And for the projections of the future of the extreme rainfall, Hong Kong Observatory used the IPCC models and used the statistical downscaling approach to recreate the rainfall difference in Hong Kong. And for example, the RCP 4.5 scenario and RCP 8.5, this case, we see that we are going to see, we ignore the 2.6, right? 2.6 is quite unrealistic at the moment, unless we have a very, what you call, very surprising event happening in the world that everybody stop using fossil fuel suddenly. But it probably won't be the case. So 4.6, 4.5, 6, and 8.5 will be much better scenarios. And we can see that the wet rainstorm, the extremely wet rainfall year will increase in both scenarios, with more in 8.5. And the dry year will still be there. So we see that rainfall will, from year to year, will become more variable. Okay? And for the extreme rainfall, that is the daily maximum rainfall. This is the actual range for daily. And in the future, depends on what scenario you use, it's going to be likely higher than what we have. And for 8.5, you even have a higher range, and with the rainfall rainfall, average rainfall higher than that of the present climate. So we will expect from the physics that we are going to see more extreme rainfalls in the future warming climate. And how about tropical cyclones? This is a very complicated topic. I usually teach this topic for 3 hours, but luckily we have 10 minutes. So it doesn't matter. I try to summarize all the salient points to talk about this point. Tropical cyclones are very basin-wide stuff. What I talk about is the Western North Pacific. That is all the way from Western North Pacific to South China Sea. It does not represent exactly the same in Northern Atlantic or Indian Oceans. So may not apply, but some of them are really applied. The tropical cyclones are very complicated topics because they are quite remote and stochastic. This is the frequency of tropical cyclones in the Western North Pacific from 1945 all the way to 2017. You can see the interannual variations are quite significant and with very significant multi-decadal variations. And there are many different dots inside here. They're actually from the data of different weather centers, from Hong Kong, from China, from Japan, and from the United States, the Joint Typhoon Center. All of them have his own analysis. They will give different number of tropical cyclones. Especially the difference will be quite large before the satellite era. Okay? Without the satellite, they rely on the ship observations and Earth surface observation. So some center may detect the storm, some may not. And after 1960s or 1970s, the situation improved, but still sometimes there are quite large difference from year to year. And in general, after 1970s, we see a decreasing trend. Okay? But is it a good news? May not be the case. For Hong Kong, they usually count the number of tropical cyclones go within 500 km of Hong Kong. And in fact, we also see the same decreasing trend, but not significant statistically. So this is quite large interannual variations. So of course, another problem is that tropical cyclones has a quite large multi-decadal variations. But we only have the data less than 100 years for all the centers. So we are not able to see the whole few cycles. So it's quite difficult to give a very clear trend of how it varies. So that's why don't be so happy if you see a decreasing trend in tropical cyclones, because there are quite a lot of variations. First one is the shift of the track. Set aside climate change, over the past few decades, we observed from analytical data is that usually tropical cyclones in our region come from here. It can either recurve to the north, or recurve to the East China Sea, or Japan and Korea, or come in the South China Sea affecting the Vietnam, Hong Kong, and Southern China. These three major prevailing paths. According to some of the research, actually quite a lot of them, in the past few decades, we see that there's a decreasing trend over here. There's less tropical cyclone come into the South China Sea, especially this region, but more recurring to here, Eastern China, Korea, and Japan, and or south of Japan. This change is quite clear and significant over the last few decades. That means that we may see a little bit less tropical cyclones affecting Hong Kong, as we saw from our previous slide. But actually, tropical cyclones maybe have a pattern to shift further to the Eastern China, Korea, and Japan. They are less commonly affected by tropical cyclones. That means they're not well prepared, but they're getting more and more tropical cyclones. For example, this year, Japan has a lot of tropical cyclones. The problem is that the frequency and the path is the two factors, but the intensity is which actually the real killer. And this one of the famous paper recently published in Nature, they checked against the number of landfalling tropical cyclones in the coastal areas. One of the clusters they checked is the southern China. You can see from this one, after checking all the data from 1970s to the recent years, there's a significant increasing trend in the peak intensity of these landfalling typhoons, as well as their intensification rate. So that means we may see a slightly decrease in tropical cyclone frequency, but each one may get stronger. Okay? You know, tropical cyclones is very case-by-case stuff. You may not have many tropical cyclones a year, but one very intense will kill. This is the problem. And in the past, we see quite some very deadly tropical cyclones in Hong Kong. For example, the 1906 and the 1937, they killed about over 10,000 people in Hong Kong. Bear in mind that at that time, Hong Kong has only around 300 to 400,000 people. So the killing rate is very high at that time. And most of them are killed by storm surge. Next one I've talked about. Okay? Storm surge caused by tropical cyclone is always the #1 killer in Hong Kong, elsewhere, and everywhere in the world. Like the one in Bangladesh that killed about 300,000 people are also due to storm surge. This is some of the picture for you to recall some of the memories. This is too far away from you. You see that storm surge can even damage the whole railway along the Total Harbour. This is the way to go to Sha Tin. Okay. And Sha Tin, at the time, Total Harbour can be flooded seriously due to the storm surge. And the whole area was completely flooded, and most of the people was killed during the event was due to the flooding over that area. And so what will happen if we have climate change and tropical cyclones? Although tropical cyclones are cases of quite stochastic events, but warming of the ocean will first of all provide more energy for a storm to develop. So physics tell us that this is going to increase its intensity if assuming other factors are equal. Okay? The other one is the warmer atmosphere. Like extreme rainfall, a tropical cyclone environment, if you get more moisture in the atmosphere, that will produce more rain from the tropical cyclones. This is quite robust from the model. So another issue that with tropical cyclones and climate change is that the tropical cyclone with related rainfall will increase likely. And the last one, sea level rise, I think it's the most confident predictions from climate change projections. So sea level rise will definitely increase the risk of storm surge and compromise the infrastructure design. So together with sea level rise and storm surge together, they will increase the risk of the coastal flooding in the coastal area. This is from IPCC. They give the rough projections of the tropical cyclones in the 21st century from different basins. You see the difference quite large from basin to basin. But if you look at the Western North Pacific, you can see that the item 1 is the frequency. They also predict a decrease slightly. And the Cat 4-5 is using the United States hurricane scale. It's the intense classification of tropical cyclone. It's going to increase in the future. And precipitation and future life maximum intensity are also going to project to be increased slightly in our basin. So according to physics, they work well with the model. And so what will the future hold in the Western North Pacific? Summarized with the IPCC together with some recent publication as also presented by a former presenter from Tom Coulson, that we will see most of the model will talk about decrease in the tropical cyclone frequency in the Western North Pacific, except the projection by Emmanuel, a project increase in tropical cyclone frequency. But for one very good consensus between the models forecast is that there's going to be more intense tropical cyclones and the extreme rainfall related to tropical cyclones. This is one of the very robust and confident predictions from the model. And the last one is the sea level rise. It will contribute towards the increase in storm surge risk. Another one is that if you have more intense tropical cyclone, the wind waves generated by this tropical cyclone will run right on top of the storm surge and sea level rise to increase its coastal damage. This is the problem. Another one is that disasters won't come one by one. They can come jointly together. One very possible scenario is that you have heavy rain, you have storm surge, you have wind waves together with sea level rise. What happened? In the old days, you have protections, infrastructure here that can sustain the wind wave together with the storm surge, and the rainfall are well contained due to the drainage system that can get the water out from the ground. But if the storm surge together with the sea level rise and increase in the rainfall and increase in the enhance of the wind wave due to the tropical cyclones all come together, you will come to this scenario. First of all, the sea level rise gradually compromise your design standard, and the storm surge increased will push the water to the coastal area, and riding on that will be the extreme wind waves that push all the water come into your coastal areas. And the heavy rain associated with tropical cyclone will put the rainfall from here and go to the sea, but blocked by this storm surge and the flood, or even flow back to the inland. So that will cause serious flooding. This is one of the scenarios that will happen. But actually, it happened. Manquit, just last month. This is the map that we create. My colleagues spent the whole month to get all the media data, Facebook data, government reports to plot all the flooding in Hong Kong. And together with all the maximum sea level that record in different stations in Hong Kong. Okay? So you can see that actually it's flooding everywhere near the coast. From the news, you may see Hanfa Tree, okay? Or some places in Lei Yu, okay? But actually, everywhere in Hong Kong, most of them with low-lying area are subject to the flooding in this case. Some even very remote area, like Dongpingzhou, Gatpo, and Tawu. The flooding are very serious and damage a lot of things, but no news report. But we go there and check it out, it was the case. And also, the storm surge induced by this super typhoon Manquit caused the storm surge set a record high of 2.35 and 3.38 meter in the Victoria Harbour and Togo Harbour. This is the highest record, even exceeds the one in 1962 of London. Fortunately, on that day, the tide was not the high tide, it was the late tide. So the sea level, due to astronomical tide, was 1.5 meter. But if it happened to be a high tide like Hartwell last year, it was 2.5 meter due to astronomical tide. Then it will be 1 meter higher than what happened to that today. This is what our director said. We are really lucky in 2 super typhoons. All right. Okay. But can we be so lucky next time? It depends. Okay. Now summing up, learn from the past that we see the extreme rainfall and very severe typhoons can affect Hong Kong and cause significant impacts. And against the background of climate change, we will expect the warmer weather will continue, and with more variable and extreme rainfall in Hong Kong. The sea level, of course, will keep rising. And with the tropical cyclones, the latest model predictions, where it's expected that it will be more intense and carry more rainfall. And together with the frequency, that will together react to the frequency of severity of the extreme rainfall in Hong Kong. And for the future, and what we are very accurate or even very well prepared for today may not be very good in the future. And so we cannot be we have to take note to that and keep raise the public awareness on the natural disasters to make sure that we are not designed for this next 10 years, next 20 years, but for the next few generations to come. One important thing is that the cross-disciplinary collaborations is very important, especially when we go on to better understand or assess the possible change in multi-hazard impacts in the context of climate change, and to provide a better scientific basis for us to further improve our infrastructure designs and formulate not just infrastructure, but the emergency preparedness measures. Okay? Thank you.
Thank you, Dr. Lee, for this very educational presentation. So now we have a very quick Q&A section. Is there any question for the 2 climate scientists? Yes, please.
Yes, maybe for both of you. What I understand also from your lecture, that the probability assessment of extreme rainfall events is difficult to assess, especially when we talk about the clustering of events. So that will probably more science will not help us to get a better feel of that. But what about your vision on the other side in terms of early warning systems? What do you expect? Our European Center for Medium-Range Weather Forecasting sets a target for 10 days for disruptive weather events. So do you feel that new technologies and better management systems will increase the early warning time for extreme rainfall events? What do we expect from from that area.
Maybe I answer first because I'm
Okay, yeah.
we're responsible for warning. So yes, exactly what you said. When I was young, I was the forecaster. We issue 3 days forecast. But now we go to outlying days, benefit from the models. For example, ECMWF and United States and Japan model. For example, the United States model, they can now go up to 30 days or even longer. For ECMWF, they have very high resolution model up to not just 10 days, 14 days. You can even buy the data further ahead, over a month. And I also see that they keep improving the model steadily and with very good performance. So I expect that in the future, for tropical cyclones like that, the model are getting better and better skilled to predict the tropical cyclones days ahead of its genesis. Days ahead of its genesis. So before the tropical cyclone formed over the ocean, maybe 3 days ahead, we know it will be formed and where it will have to and how intense it will be. So the public can become more aware of the situation. It's just like what happened in Hong Kong now. Everybody talking about the tropical cyclone Yukto over the Pacific. Okay, so that will help. And actually, the case of Manfred, all the models perform. I don't have the slides here, but all the model performs very well. We know that it will pass through Luzon and go to South China Sea and come very close to Hong Kong, and with a very significant intensity that will pose a real threat to Hong Kong. So that will give a forecaster and us and the engineering department very good confidence that we have to prepare. So at that time, I think interdepartmental discussions, announcement, ask the people to really take up the awareness. This time's really real and with great impact to Hong Kong. And so the people are doing a lot of things, tapping the windows, etc. And so this is good. Early warning is one of the ways, apart from engineering solution of preparedness, early warning is one of the very important stuff. In the later on, I expect when we have even better models from ECMWF, for example, they will give the forecast up to as 14 days with good skills. So that will help us to predict the situation. One thing, the most important, is that the skill of the model in predicting the extreme rainfall are still quite limited. But we are using some probability data from ECMWF, for example, EFI and SOT data. That is the parameters to predict how extreme the rainfall will be, to assess the probability. But this is still under development. But in the future, if we have 2 to 3 days ahead for the extreme rainfall, that's already very good for our warning, for the preparation of engineering departments to do their preparation work for against flooding. That will be very good.
Okay, I just want to add something to that. I think it also depends on the place because, for instance, especially in tropical regions in my place, we have like local convections, like the dominating pattern of the rainfall. So when you have this very short scale time and space, and then that's really hard to predict. Even the next 3 days, you can predict maybe the next day or the next hours, but next 7 days, this is not easy. I think we will reach some progress in the future, but it will still be a challenge. It's different when we talk about like large scale, like hurricanes or frontal rainfall. But I also like to think about the probabilities. I think at least when you look at like these large scales, when you think about the extreme events, I think we have some chance to improve the forecast, at least for the extremes. And when you say that's like the stationary probability is 1%, and then if you change to 2 or 3%, it doesn't matter anything. But you say, okay, the probability of this extreme event will be like 50%, from 1 to 50 or to 90%. And then you have some fields, okay, we need to do something. But if you are like in the range of very close to the stationary thing, not that much. But I think at least this, if you change a lot, you can do something. Same thing for floods. If you say, like we had that early warning system for the Manaus city, like small change doesn't matter anything. Doesn't mean anything. But big change, like when you go to these big numbers, people say, "Whoa, you need to be aware. This is a big change."
Okay, I have one more question, maybe.
Question for Dr. TCV. So all engineering designs very often rely on specified rainfall of certain retain periods. So based on, if we also consider climate change, then how often should we update such kind of design values?
Very good questions. This also pursued me for quite a while. When I was young, again, yeah, exactly that we provided data to engineering department or the academic. They will use the past data, for example, 100 years data to do the GUV, etc., to get the return period for our engineering standard. That's used by, I think, around the world. Depends what return period you use. Some people may use 50 years, 100 years, or 1,000 years, depends on the risk. And this is quite a good engineering approach. The same applies to PMP, the probable maximum precipitations. That you define that the heaviest rainfall you can expect due to the physics in your area, then you pick the percentage of PMP you use for design, right? This is the way the hydrologists use this standard. But in the last decade, I'm still very young, we find that the change is quite fast. That the standard we usually update every over 10 to 20 years may not be able to catch up change. So one very interesting example is that we have the probable maximum precipitations. Right? That was designed in 1960s, for example. When we go to 1980s, after all the data collect, we find it increased, for example. But that means the probable maximum precipitation in the past is not representing actually probable maximum precipitation. It's just probable maximum precipitation at that time. This is the problem, right? If we do it now, we have the probable maximum precipitation for nowadays. But if we go to the future, how can we define the probable maximum precipitation? That is a very academic question. The same applies to return period. Okay, this is the one way we may need to think about this is that keep updating the return period against the climate change will be quite passive. This is the engineering's problem and scientific problem. Yeah, some of the, for example, for PMP cases, some researcher will use the future modeling to include into the past data and the future data to recompute the probable maximum precipitation. How can they change? So they give the higher ceiling or room for the climate change impact on that part. But can we do the same thing for return period? That is a quite academic questions. Need to be proved in the future. But it's quite a problem, I think, for quite of the engineering community that the return period concept against the climate change sometimes can be quite passive, especially you cannot change the standard all the time. Every year you change the scope of practice. This is not practical, not pragmatic, right? This is the problem.
Okay, thank you. Because of the time, so let's have a break. So 10 minutes, we will continue for the rest of the presentation.
車爆咧，爆住你上街咧就好似雪崩咁樣，所以呢個就即係其實可能係設計城市嘅。
What we have is the stakeholders, do you now all sorts of questions regarding, and then they can determine. And then that generates this type of spider diagrams. And with those spider diagrams, we interact with those. And that is a way to assess the resilience. It's not a quantitative. I think, so, if you're interested, I can send you some of this information. And then there is another Oh, yeah, okay. Hydro. Excellent. Yes. Yeah.
That's just the short clip for the elevation. We have the same thing, you know, from
散出寫出去咧，即係嗰份嘢。咁啊，as long as 佢有嗰個
Yes.
即係空氣個變化先。我飛機冇，因為我啲飛機師傅最高嘅，飛機基本上我哋正常嘅量，當然啦，你有啲情況，如果真係打爛咗你嗰啲 efficient，打爛嗰啲 efficient。咁但係就正常嘅擊咧，飛機我哋做，就算打中咧，都未必一定即刻有事。即係而家啲飛機好少做，基本上我有機師嘅飛機，你個機師係嗰時整埋，唔該晒。
That's your big project. Yes, and hopefully because then after you set the runway, you kind of set it in. I left the text in over just before cascade. And then you know that if I'm not there, then it's not there. Now, but also it's very clear that it's difficult But in that simplification, information is not all. You have to simplify it to make it more. But that's not always justify the real situation. But you have to
Right, so it's about time for the second section for this workshop. So we have heard a lot about what happened from the sky. So for the following two presentations, we are focusing on what we'll be receiving on the ground. Okay, so the first presentation is more on the landslide problems. So today we have Dr. Julian Kwan from GEO Geotechnical Engineering Office, one of the Hong Kong Civil Engineering and Development Department. So he is now in charge of technical development work in GEO to support the formulation of slope safety policies, including the strengthening of the emergency preparedness against landslide under extreme weather events. Okay, so
thank you very much, Anthony. I'm from GEO Geotechnical Engineering Office. Basically, GEO is a technical arm of the Hong Kong SAR government to take care of the slope safety or the landslide risk management in the city. And today I'm happy to share with you our experience in strengthening resilience against landslide hazard under extreme weather. So, as I mentioned in plenary 2, the situation in Hong Kong is unique in the respect of landslide risk. We have densely populated development close to natural hillside. And more importantly, we try to have more space, and then therefore in the past we cut a lot of hillside and then create many steep man-made slopes. However, we have very unfavorable geological setting. We have a quite deep weathering zone overlaying our steep hillside. Therefore, whenever there is an intense rain, heavy rainfall, we have a high chance of having a landslide failure close to our development. And as mentioned by TC, our colleagues in HAO, Well, in recent years, we have many mishaps happened around us. For example, in 2009, in Taiwan, they are hit by a super typhoon Morakot, and it caused multiple fatalities. In one of the extreme cases, a landslide developed and into a mobile debris flows, and then it kills several hundred people in one go. Hong Kong, well, as a neighbor cities of those cities, we are not immune from the extreme landslide or extreme weather events, I would say. In the following 15-20 minutes, I will share with you GEO's experience in gearing up our city's resilience against landslides. I want to share with you our experience in 3 aspects. The first aspect is to understand the landslide hazard under climate change. It's a sort of diagnosis of the risk profile. Under the effects of climate change, what the landslide risk or the source of landslide risk will change. And second, I will talk more about how do we enhance our adaptation measures. They are, the most of the contents here are related to the engineering solutions. And before I end my presentation, I will talk more about how we strengthen the community resilience. So first of all, let's start with the diagnosis of what will happen under the climate change effect. This slide here, I won't go into details because my colleague TC has already explained it well. Basically, the story that the chart tells us is we may have a higher chance of having a more frequent intense rainfall in those days. But one thing, the trend may not be true because perhaps we may need to observe a longer period in order to identify the real trend. But anyway, something for sure, whenever we or Hong Kong is hit by heavy rainfall, many damaging landslides will happen. And this is the photo that TC explained. Maybe I explain a little bit more. Well, we have what happens is that in the 2008 extreme rainfall that hit the West Lantau, there are many natural terrain landslides happen on the hillside. And then many of the landslide debris materials get into inside natural drainage line, and then they mix with water and develop into a debris flow. And subsequently, the debris flow dash down from the drainage line and then rush into the North Lantau Expressway, which is the only way or the only connection between our airport and the city. And it blocks for, if I remember correctly, this incident caused the blockage of the road for 16 hours. So the airport was isolated for almost longer than half a day on this day. And when I've just mentioned about debris flows, and this is the debris flows trail that we pictured after the 2008. This is the Yudong Road. This is not the NLE. This is not the North Lantau Expressway. The North Lantau Expressway is around the corner here, so they are very close together. And on the same day, well, the similar debris flows occur along this Yudong Road. And one of the member of the public video this Yudong Road debris flow and then put it on the YouTube. Perhaps I can share with you what happened on that time. This is the landslide scar, and then this is the inside drainage channel. As I mentioned, well, the landslide debris mixed with water and developed into a debris flow. They are fast-moving monster. The maximum flow velocity is about 10 meters per second. It possesses a very destructive power, a very high destructive power, as you can see. All the big trunk of the trees beside the road on the slope was damaged. They are all down. And the debris flows carry those large particles and soil materials deposit along this road on at the hill top. So this is the kind of thing, this is the kind of hazard that we have during intense rainfall. Actually, there are quite a number of natural terrain landslides happen on our hillside. But most of them will happen during normal rainfall or typical rainfall. The rainfall intensity is not high. And at that time, because there are not much surface water, the mobility of the landslide debris is not high. And therefore, debris will stop on the hillside without affecting development in most of the time. However, as the speakers in the previous section mentioned, we could have a more chance of having intense rainfall. And in this case, based on our experience and our landslide statistics, we understand that, well, intense rainfall would cause more landslides, more number of landslides. Some of them may be massive, and most importantly, those water mixed with landslide debris result in a debris flows. And those debris flows are fast-moving incident or fast-moving monster, I would say. And they will travel a long way, a longer way than what we have in the usual day. And finally, they will reach our development. When I say they are fast-moving, I mean that the velocity is high, right? So the high velocity also encompasses the debris flow with a higher erosive power. What I mean is, when they have higher erosive power, when they run down their run-out path, they will try to scour, say, soil and boulders into themselves so that their volume become bigger and bigger. And in this way, when they reach our development line, they would even have a higher destructive power because of the boulders and the larger volumes of soil material they engulf. This is a sort of scenario. But in order to ascertain or having a more clear picture of what will happen under the extreme environment posed by the climate change, we do two scenario-based analysis. And in the first analysis, we assume that the 2008 intense rainfall that hit Lantau would hit our Hong Kong island. And in this scenario-based analysis, we find that there could be as high as 200 to 300 number of landslides impacting buildings or roads. And most of them are from natural hillside. Another scenario-based analysis that we have done, the second one, is that we transpose the heavy rainfall from the 2009 superstorm Morakot that hit Taiwan to Hong Kong. And we find that, we estimated that, well, there are over thousands of landslides would hit roads and buildings. It would be a very overwhelming event. A widespread of landslides that hits Hong Kong may happen. Again, both of the analysis tell us that our natural terrains or natural hillside react more strongly comparing with the man-made slopes. So therefore, well, the scene is set. Our risk profile changed from man-made slope to natural terrain under the threat of climate change. So we are facing the challenge from the natural terrain hazard, and we have some ways to enhance our adaptation. And in the following slides, I will share with you our experience in that way, and also I will introduce to you some of our recent technical development initiatives in order to enhance our engineering solutions. In the past, we take continuous improvement initiative to improve our slope design in order to guard against the effect of climate change. For example, we promote robust design, slope design by asking our practitioner or industry to reinforce our slope using saw nail. This kind of engineering design is more robust because they are less sensitive to rise in groundwater table. This is one of the initiatives. The other initiative is slope maintenance. Based on our experience, lack of slope maintenance is one of the major contributory factor of man-made slopes. For example, the blockage of a drainage channel would cause overflow of water during heavy rainfall, and then eventually it will cause washout of the man-made slope. So therefore, since late 1990s, we direct our effort in promoting proper slope maintenance to both government departments and private property owners. And more recently, we update our design guideline of slope surface drainage to include climate change effect. As I mentioned, well, there's a change in the landslide risk profile, and therefore, since 2010, our office implement a landslide prevention and mitigation program. Under this program, in addition to deal with or upgrade the substandard government man-made slope, we spend some of our money and resources to identify vulnerable lateral hillside, and we carry out mitigation measures for those hillsides. As you can imagine, our technology or our engineering solution which upgrade or stabilize man-made slope won't work in this setting. We are not able to stabilize this huge area of lateral hillside. Therefore, we build mitigation measures like landslide debris resisting barriers to protect the major facility at the slope toe. In the following two slides, I'm going to share with you our recent initiative of technical development work in the respect of landslide hazard identification and the design robustness of barriers, so as to upgrade our adaptation capability. In the first initiative, we try to use deep learning or method in order to train the computers to identify landslide from aerial photos. In the past, our engineer, one thing, GEO actually keep an inventory of lateral terrain landslide. Every year, our engineer will scan through aerial photos in order to identify lateral landslides or land sizes within the Hong Kong territory, and we form an inventory so as to allow us to assess the vulnerability of our natural hillside. And every year, our lands departments produce almost about 10,000 aerial photos, and it is quite time consuming, and we spend a lot of resources in order to scan through all those aerial photos for updating the inventory. Therefore, we have this initiative. We team up with PolyView and try to develop a using sort of a pattern recognition techniques, and to train the computers to identify landslide source, for example, from those aerial photos. Hopefully, we can have a shorter turnaround time in the updating of our landslide inventory. The second initiative is about technical development work, which helps to enhance and optimize our engineering design. Just now I mentioned, well, fast-moving debris flows will engulf boulders and things like that. And this is one of the photos we took after the 2008 debris flow. And you can see there are many, many huge boulders. And boulder impact load is large. And and is quite a big concern in the design and also in the assessment of the barrier stability. So nowadays in our design practice, we use quite a, I would say, onerous boulder impact load. But we want to optimize it. Also, we want to see how well our barrier will perform. Therefore, we team up with University of Melbourne to carry out large-scale impact tests. We use this kind of pendulum type of impactor setting to simulate boulder impact, impacting on rigid barriers. We do a lot of measurements, say displacement and also strength measurements. And we did a series of tests, and this is the last test, and this is the destructive test. We want to see some extreme failure mode, for example, the scuppering and things like that. And the study is ongoing, and we hope we can, through the study, we can obtain more insight to optimize and to enhance the robustness of our barrier design. We also team up with HAUST to do a lot of room tests to understand more about the characteristics of local debris flows. And tomorrow, Dr. Karen Choi of HAUST will have a presentation in the workshop to tell you more about the flume test. This is the last part of my presentation, which is about GEO's effort in enhancing the community resilience. As I mentioned, no matter how well or how good our engineering solution is, there are always a residual risk. There are always risks associated with it. Risk can never be brought down to zero, and therefore we think that in order to mitigate those residual risks, we need to, for example, keeping our public's awareness of the landslide risk under extreme weather, and we do promote the message through TV advertisements like this one.
山泥傾瀉警告現正生效，市民應遠離斜坡。
冇以為咁嘅場面喺電影先會出現。極端天氣近年喺世界各地觸發嚴重嘅山泥傾瀉，災難萬一喺香港發生，我哋要配合政府嘅緊急行動，你同我都唔可以置身事。
今早廣泛地區受。
So apart from the advertisement on TV, we do a series of community activities like school talks, exhibition, and we also partner with NGO like Red Cross to reach out villagers to tell them the risk they are exposing. And also we prepare teaching kits for secondary school students to tell them more about the landslide risk and the geology of Hong Kong. Also, we use the social media, Facebook, to disseminate messages about landslides and things like that. This is the Facebook page. This is a screen cap of the Facebook page, of our Facebook page. And in this Facebook page, we actually tell our people the updated status of the mitigation work of a landslide site. And as mentioned by one of the panelists, at the end, if an really extreme weather events comes in and hit us, there would be an overwhelming situation. So in recent years, we also appreciate this kind of thinking, and therefore, nowadays we try to promote self-help tips in order to reduce public's exposure into the landslide risk, especially during heavy rainfall. My colleagues in the public communication unit are very up to date in terms of using the latest technology. More recently, they use the VR technology to produce or to prepare a virtual reality videos in order to in order to let the public to experience what really will happen during landslides. It's a sort of boosting up the public's awareness. And also, we team up with university to use the latest mobile technology, the IoT technique, to invent or to develop a landslide detection system. The idea is that we put those sensors behind the barrier, and when the sensor got hit, they will send signal to our iPhone or cell phone to our officer in order to mobilize timely emergency response. So in summary, I will report to you our experience in managing the landslide risk under the threat of climate change. Well, we try to understand the risk profile under the climate change, and also how we enhance our adaptation and the work we have done in the strengthening of community resilience. This is the last slide that I want to show, and I think I perhaps repeat some of the speakers has mentioned. I think at the end, we need a concerted effort from the society. All sectors across the society should join hands together in order to build a more resilient city. So, thank you very much. Thank you.
Thank you, Julian. Thank you. So we have another speaker from the Drainage Services Department. So we have Engineer Raymond Moon, who is now a senior engineer in DSD, Hong Kong government. So he's currently overseeing the drainage planning, blue-green infrastructure, flood resilience, and climate change issues for the department. So he'll share with us the current situation about flooding in Hong Kong. Thank you. Raymond. Thank you.
Good afternoon, ladies and gentlemen. I'm Raymond. I'm a senior engineer from Drainage Services Department. I will go into share our flooding challenge in Hong Kong, our stormwater management, and how we do blue-green infrastructure for combating climate change here. Drainage Services Department, or DSD in short, has two core business. One is on flood prevention, and the other is on sewage treatment. We established in 1989, 29 years ago, and we now have about 1,900 number of staff, and among which 300 are professional staff. Our mission is to provide world-class wastewater and stormwater drainage services to enable the sustainable development of Hong Kong. And today, this workshop is about water, so we focus on flood prevention and stormwater management. And let me ask you a question. Why stormwater management is a real challenge in Hong Kong? Yes, perhaps we can see this figure. Hong Kong is here. We almost have the highest annual rainfall in the Asia-Pacific region. We are about 2,400 mm on average every year. And this is about 2 times of Sydney or 4 times of Beijing in mainland China. So in short, we have a very heavy rainfall. And in Hong Kong, we also have a very distinct wet and dry season. Most of the rain will pour down in the summertime from April to October. We only have minimal rain in the winter time. So how to tackle this challenge? We adopt a 3-pronged approach for flood prevention. In the upstream area, we do it by interception. Maybe I'll play again. Yes, in the upstream, we build the drainage tunnels here to intercept the runoff from the uphill area, and then through this tunnel and discharge the runoff directly to the sea. So it can prevent the rainwater from running down to the downstream BCA area. In the midstream, we do storage. Here we have an underground storage tank which can store temporarily the rainwater so that it can reduce the flooding risk in this low-lying area. And in the downstream, we carry out drainage improvement work. We upgrade the pipes in this area to increase the capacity. So why not take a real example? This is Hong Kong Island, and the hillside is here. Here is Landslides. This is the Hong Kong Convention and Exhibition Center. This is our beautiful Victoria Harbour. Okay. So at the uphill, we have this intersection drainage tunnel. Okay. The rainwater will run and then be collected by this tunnel. Okay. And in the midstream, we have storage. Here is the Happy Valley race course. Okay. This is the football pitch area, and we have underground storage tank like this to temporarily store the rainwater. And of course, near the seaside, we have a lot of drain pipes, box covers to get the rainwater discharged to the sea. This is our three-point approach. So let's see some water. This is the Hong Kong West Drainage Tunnel you just see from the mid-hill. And this is about 7.25 meters in diameter. A double-decker bus can walk inside. Okay. And during the heavy rainstorm last year, you can see the water is about 2 meters. 2 meter high, flowing. And this is in the midstream, the storage tank at the Happy Valley. So when the rain are heavy, we introduce some water to this storage tank. And the volume can store about 60,000 cubic meters, which is equivalent to 24 standard Olympic swimming pool size. 24. So, since our establishment of the Drainage Services Department in 1989, we spent about 28 billion Hong Kong dollar for the drainage flood prevention assets. We now have 4 numbers of drainage tunnels, 4 stormwater storage tanks, and we also have 2,400 km long storm drains, and some river channels and village polder scheme. With all these flood improvement drainage projects, over the past 20 years, we have reduced the number of flooding bad spots significantly. You can see in 1995, we have about 90 bad spots, and some major bad spots means major flooding. And up to this year, we only have 6. And they are only medium, small, or minor bad spots, just local flooding, no more major one. So, is it our job well done? Can we be satisfied with what we have done today? Or can we be satisfied with the present condition? The answer is no. Why? Perhaps the polar bear can tell you the answer. It's climate change. That's why we all are here today. Okay. And climate change is real and affecting all parts of the world, including Hong Kong. According to the 5th assessment report by IPCC, and also our downscaling analysis by Hong Kong Observatory, they do some research and analysis. We project the rainfall increase in Hong Kong will be 10.4% by mid of this century. And by end of this century, it will further increase to 13.8%. That means we will have more and more heavy rainstorm in the years to come. And a back warning storm, we should have more and more in future. So, how to tackle this challenge? In addition to the three-point approach, there are many adaptation measures and hard engineering measures. we want to introduce the blue-green infrastructure concepts, which are more flood resilient. And blue means rivers and water bodies. Green means greening and biodiversity. And this has similar concepts of the spongicity in mainland China. So, we cannot avoid the heavy rain, okay? But we can control how it affects our city. When it comes down, part of it, just like a sponge, can absorb part of the runoff, so that the amount of runoff can be reduced a little bit, so that to reduce the flooding risk to our city. And blue-green infrastructure concept has 6 major elements: infiltrate, detain, store, purify, reuse, and discharge. Let's look at some practical examples in Hong Kong. Infiltrate, we can build green roof at our pumping stations and also some building structures at our sewage treatment works. And because the rain can infiltrate to the green roof, to the soil, to the vegetation, the amount of runoff can be reduced a little bit. Similarly, for our pedestrian footpath, instead of hard paving, concrete paving, we can build porous pavement. Some of the rainwater will be infiltrated down to the earth, so our runoff again will be reduced. Detain, this is the flood lake at Samjiang River. Normally, the water will run along the river like this, in this way. Okay, but during heavy rainfall, some water can go inside to this flood retention lake for temporary storage. So the rainwater here will not be over bankful and flood this adjacent area. This is a temporary storage concept. And again, this one you have just seen is the Happy Valley underground stormwater storage scheme. This is the race course, and we make use of this land, the underground, okay, to build the storage tank of 24 standard Olympic size swimming pool to store 60,000 of cubic meter water. And this is about 3-point-something high, just like an underground basement car park. And normally the water will go through here, the box cover underground, and then to the Victoria Harbour. But during heavy rainfall, some of them will be diverted here to go into this stormwater tank. And after the rainfall, when the water subsided, then this rainwater will be discharged gradually and finally to the sea again. Purify, we have some bioswale and rain garden. The vegetation can purify and the water pollutants at the runoff. It also improves the water quality. You know, Hong Kong is now promoting a more livable city concept. So with all this, it's not just greening. It has some usage on purification of water quality and also some storage purpose. For reuse, we have water harvesting system, and some of the stormwater will be treated and then for irrigation to our plants. Water is actually a valuable resource, so it's good to save some drinkable, potable water, and then we use stormwater for irrigation and also for some street cleansing in some area. Last, for those excess water, we have no choice but discharge. In the old days, we have concrete channels, concrete rollers to discharge the water efficiently to the sea. Nowadays, we do river revitalization. Kai Tak River is the first one in our urban area. Originally, they are quite ugly. Now, we beautify them and make it introduce some landscape measures and improve the walkability and appearance, so that the high-rise building in the adjacent area, many people living around here and walking around here can enjoy a beautiful river. And in the rural areas such as the lower Lanchin River in the New Territories, we have more space. Then we can introduce more greening and more biodiversity into the rivers to improve the ecology as well. Looking forward, we have more full green opportunities. Most of them will be introduced in our new projects and new development areas, such as the Anderson Road quarry site and also the Dongchong. For the Anderson Road quarry development site, we are building the first flood retention lake, but with land co-use and floodable concept. What is land co-use? Actually, this one is just like a normal open space, a normal park. But this area can also be used for flood storage during the heavy rainstorm. So this is land co-use. It's like this. So during heavy rain, all this area, the water level will increase and then will be flooded. Okay, and this can hold temporarily the storm water for storage to lower the flooding risk. Another one is the Dongchong River Park. In the Dongchong River, we are going to build a river park. The concept is we want to promote the water-friendly culture. We want the people to get closer to the water. Water-friendly culture is relatively new in Hong Kong, but it is good because people can get closer to the water bodies, to enjoy our environment, to enjoy it just like a park. So, to introduce something new in government or in Hong Kong is not easy. How can we do it? I think we are not alone. We can have collaboration with the industry and also the academics. Every year we do have the research and development R&D forum to exchange the ideas with the industry, our consultants, contractors, suppliers, and universities, the professional institutions. And we also have academic gathering specifically for the universities. The professors are our good partners. And in the coming 5th of December, we are going to have DSD R&D forum. The theme is Smart City Innovative Stormwater Management. You all are welcome to join. It's free of charge. Right? It will be held in the Hong Kong Science Museum in Jinsha. And on international level, we also have good connection with overseas cities. Hong Kong is one of the C40 cities member, the CARe leadership group. And Drainage Services Department is one of the Connecting Delta Cities member. We exchange ideas with other Delta cities like Rotterdam, New York, Singapore, all these cities, all on coast to the coastal area, to exchange our resilience strategies to combat the climate change. Right now, the Connecting Delta Cities workshop is being held in Italy, and our colleagues are already there in Italy to exchange with other countries. And further, we will work with the international professional institutions like IWA, International Water Association. And next year, from October 31st and 2nd of November, we will have an international conference co-organized by IWA, CARe, Drainage Services Department, and also Water Supplies Department. We hope we can exchange some smart solutions for water resilience to promote further the flood resilience concept in Hong Kong. To sum up, I have mentioned about the three-pronged approach to combat the flooding challenge in Hong Kong. And I think the key of success is collaboration. We cannot do it alone. We have to collaborate with other government departments, with the professional industry, with the academics, with the general public. So I think with collaboration, we could have more green infrastructure and we can improve the flood resilience in Hong Kong. Thank you.
Right, thank you, Raymond, and also Julian for the excellent talk. So because of the interest of time, may I just start the panel discussion for the time being. So may I invite all four speakers to the stage. So, is there any question, maybe starting from the floor?
So I have a question for Raymond. You mentioned one of the new pigment, the pigment that can actually enable infiltration. So that's already a collaboration going on, or and how much, because we have so many roads in Hong Kong, what is the current coverage of such a new pigment?
Yes, the question is about porous pavement, right? And actually, most of the footpath or roads in Hong Kong are maintained by highways department. Okay, and actually we have good collaboration with highways department. And actually, I worked in highways department long time ago. Yes, and for our pedestrian footway, we will use paving box nowadays, and that paving box cannot as porous as our porous pavement. But porous pavement, they have similar costs actually. They are not very expensive nowadays. So we are actually encouraging the highways department to implement more porous pavement in Hong Kong. One big example is the newly opened Hong Kong-Macau-Zhuhai Beach, the boundary connection facilities. That means the border center. If you have time, you will know there is a public transport interchange outside the boundary control facilities. There is a big podium, and all this pavement, the paving blocks are not the standard paving blocks. They are the porous pavement paving block. It's about 16,000 square meter, which is about 2 football fields, very, very large in scale. So actually, Hong Kong is constructing more and more porous pavement now, and we really encourage our new projects. The new road projects or the new development, new town projects to build porous pavement.
How about the old road? You think that it's also possible to replace some of them when they due to be repaired, and there is a plan for that? Like whenever there is a road broken, then we don't have to go through so much negotiation and discussion. We just will replace those new pavement materials, or it's still under discussion?
This is a good direction, and we always encourage our highways department to do it just as what you said, because it doesn't involve too many extra costs and efforts. It's a mindset, because some people, if they have never get touch with such new things, they will just use conventional method to do the things in the old way. Okay, but if this is something new and something proven, right, and they will understand the advantage of it, and then we educate them or we encourage them to do more, then I think in the coming years of time, you will see more and more everywhere. This is also our wish.
Same question to Raymond. You talk about a lot of flood resilience on the source in the setting of rainfall from the hillside and also storm. But how about the flooding due to the storm surge and in the low-lying area? Any measure that Drainage Services Department is looking or studying in terms of this directions? And also one more follow-up question is, how about that apply to the new developments such as the regulations and so on?
Okay, this is a good question. Because this workshop 2 is about stormwater, and workshop 3 is about sea, you know, okay. So that's why I haven't mentioned about the sea level rise. But actually, I have I have some better slides. Yes, actually, as a coastal city, we anticipate sea level rise. So again, by mid of the 21st century, we have 0.23 meter rise, and by the end, 0.49 meter. But I think sea level rise is gradual, but storm surge is really a threat to Hong Kong. So, say we can have some structural measures, just like in Yuen Long area. We are now exploring to build a tidal barrier at the estuary of the river, so that this is the Yuen Long Tang, okay, this is the Yuen Long Lower. So because of high tide and storm surge, the seawater will backflow to the town through this river. So to prevent the backflow of water, we build a tidal barrier to resist it, like this. And if it rains, we can have this pumping station to pump the rainwater to the downstream to prevent the flooding of the Yuen Long Tang area. This is some kind of what we call the barrage scheme or the tidal barrier. This is quite something new in Hong Kong, but something very familiar in the overseas countries like the Netherlands, the Delft. They built it 60 years ago, okay? But because our sea level is not rising that rapidly, and because in the past we don't have, at least in the past 10 or 20 years, we don't have very serious storm surge. But last year, Super Typhoon is a wake-up call. This year, Typhoon Bangkok is another wake-up call for us. So I think the whole government is now, led by the civil engineering and the development department to look at the sea level issue. And we Drainage Services Department also participates to see what we can do for our drainage system. We do it collaboratively. But other than the structural measures, I would also mention about non-structural measures. Sometimes, we cannot predict how high the super typhoon will come, how high the storm surge will be. We need to have a sense of crisis. We need public education. We need some flood resilience measures. Say, using the super typhoon in September is an example. 3 to 4 days ago, we know it will come to Hong Kong. It will attack Hong Kong. So in Tai O is a low-lying coastal village. And we erect the demountable flood panels, okay, to make the seawall higher, okay. And then you can see from this photo, this is flooded. But with our flood panels, the inland here is flood-proof. Normally, this seawater level is 1 to 2 meters below here. But now, with the storm surge, it is 1 to 2 meters higher. Actually, 2 something meters higher, and almost reach the top of these flood panels. Luckily, there is no overbank for this event. But As I just said, we do need to have some non-structural measures. We need to carry out more public education to increase the sense of crisis and sense of self-rescue, to tell them what to do in case something very, very serious happen in Hong Kong. So we have some evacuation drill, public education, and we strengthen the collaboration. For the case of Tai-O, we set up a command center to coordinate the efforts of all departments, the fire services, police, all different works departments to work all together to resolve the issue, to help the people, to get them safe. So this is a new direction for our resilience in Hong Kong. This is something we seldomly do in the past because we are very lucky we don't have very serious natural disaster in the past. And do you want to add something? Julian?
Yes. First, I want to echo what TC just told us. When during crisis, during crisis events, especially when we are hit by extreme rainfall, and at the same time we have typhoon and high tides and storm surge like that, there could be a chance that we will be hit by multiple hazards, like massive landslides happen at the same time with flooding, things like that. And people we want to evacuate from our hillside will need to have, let's say, a shelter or things like that in order to evacuate them to a safe place. And at the same time, if this kind of situation happens, we want to evacuate another group of people, perhaps, into the same place if we do not have a coordinated effort. And this is actually a wake-up call for us to work together with different departments and to coordinate our rescue effort and also emergency preparedness effort. I think this is the way that we are heading to. Yeah.
Yeah, I do have a question to ask our colleague traveling over 30 hours from Brazil. We don't want to let you go easily. Now, and you finally said this morning, I think this is a global problem. And of course, we cannot vote for your president, okay, at your choice. Now, do you see what's the minimum we can do from this part of the world? And I do see a quite similarity between Brazil and Hong Kong. There are similar problems going forward.
Yes.
And what do you see minimum we can solve? To help you guys to help us.
You mean in terms of mitigation or adaptation?
Yeah. Of course, we cannot pump a lot of money across.
Yeah, that's one option.
Yeah.
I mean,
it's unlikely.
Yes. I think.
I'm just saying some sort of technology transfer, education, for example, dual degree program, exchange students, and also that's I think probably minimum we can do.
I think this kind of conference is really nice. That's one point of we can like exchange ideas. I'm learning also a lot here. I mean, it's amazing what you guys are doing. I think if you have, if you think about like universities, if you can improve like this kind of collaboration, exchange, I think exchange of ideas and students and this kind of thing, it's a very good thing at this level, let's say university level. At a higher level, I think it's more difficult to think about like how we can do when you think about like mitigation, and I told you about like the Amazon deforestation, these kind of things. One, we have funding also. There is some international funding to fight deforestation. It comes from many countries, and Amazon has this funding. That's one thing. Let's see what else how you guys can help. I think that's one way.
Another one, maybe I'm not sure if you can have some international pressure because of these issues. Especially I don't usually I don't like to talk about politics, but nowadays it plays a big role. So if somehow you guys can show, especially the politics, how important climate change is, how important it is to keep the forest and these kind of things, it'd be nice at this higher level. But
thank you. Maybe I'd like to extend my question to our three gentlemen here from Hong Kong. So now there's a hot topic, GBA, across the border. What can we do in Hong Kong? Obviously, they don't want to pay so much money to build a wall and we're done.
You mean, Charles, you mean enhancing the resilience over the region?
Yeah,
across the region?
It's not obvious, it's a big topic. It's not just confined to Hong Kong per se. And also now Hong Kong is part of China. And also our chief executive, obviously she wants us to help them too, to a certain extent. But maybe they help us another way. So you are three experts of different fields.
It's something not technical, perhaps, because the first thing that dashed in my mind is collaboration, of course. When we have the plan that sees tell us the development of the big base area, Greater Bay areas. We normally talk about collaboration to enhance the economy, and other things like technological transfer, and how we build a more smart city, something like that. But it seems that no one has mentioned about let's collaborate to make us become a more resilient region.
So this is exactly the point I'm worried, because we are left out. Okay, they never mention us in this room here. Right. Any topic related to us. That is a problem in some way. Actually, obviously, they have lots of problems over there. I don't know how to make people aware. Actually, just purely talking about economical growth without a resilient city is a sort of hopeless.
If from the meteorological aspects, we've, in fact, Hong Kong Observatory, when I was young again.
You're very young.
Yeah, I'm still young. We have been working. Thank you. We have been working with Macau and Guangdong provinces for quite several decades, including my previous boss here, Mr. Leung.
So you imply he's an old man?
No, I mean when he was young. When he was young. So in fact, because meteorology, the weather does not look broader. So we have the data transfer, data communications, and for example, during the typhoons seasons, we receive the data from Guangdong, Macau, and Zhuhai. Zhuhai also oversees the stations on the South China Seas. So this is critically important because we can see the actual wind data and pressure data. So all this collaboration has been for decades, well before the Greater Bay Area collaborations. Of course, running on the Greater Bay Area initiative, there are more. We can see this as another opportunity for us to improve our resilience, rather than just academic or operational collaborations. For example, our counterpart from GEO in Guangdong or Macau can work together to share what we call the experience. Because each city has its own policies, own consideration politically or financially, but the technology can share, the experience can share. That can help to build up the resilience. Once we have the Greater Bay Area, the cities, the economy, the people are connected. One place get a problem, the other place may be in a chain effect be affected. For example, the bridge between the Zhuhai, Macau, Hong Kong. It takes time for us to negotiate between the parties about the warnings, right? When we close the bridge, etc. This is the collaboration that we need to do in a soft way, rather than we must to force use the same standard, because many political and financial considerations. But from the technology perspective, many of our approach depends on the terrain, topography, and the special city design. We can do share our experience to how to deal with different kind of disasters.
And from Chinese perspective, we are actually collaborating with Guangdong a few years ago. And you know, in Hong Kong, there is a joint liaison group for combating climate change. 粵港澳氣候變化協調小組 in Chinese. Okay, a few years ago, this is led by our environmental bureau, and Chinese Services Department is one of the members to talk something about climate change aspects, but in particular with about stormwater management. And because although Chinese is the Chinese infrastructure itself is local, okay, our one-off in Hong Kong will not go to Guangdong, okay, but we can still learn from each other. In particular, the implementation of spongy city in mainland, in Guangdong, Guangzhou, they have done a lot in much large scale. We can learn a lot from them. The operation point of view, the maintenance point of view, we can learn from them. And the other cooperation, I think, is with Shenzhen. Shenzhen is just north of New Territories. We have a Shenzhen River. Half of it within Hong Kong, half of it mainland Shenzhen. And you know, there is a reservoir, Shenzhen Reservoir, and when it is charged during very heavy rainfall, it will also affect the northern part of Hong Kong. So again, under the Greater Bay Area, we will strengthen also the collaboration. And I think in terms of drainage, stormwater management, how can we regulate the water from Shenzhen Reservoir and also Shenzhen River? We can have further collaboration in this area. Okay.
If I may follow up on one question related to what you just said. Actually, I like your underground reservoir.
Storage tank.
Yeah,
yes.
That's a heavy rain.
Yes.
I guess that is not open for public use for car park during the dry season, right?
No.
No, actually, it's quite area. And I can quote an example, actually, in Malaysia, KL, they have a tunnel. During normal, when there's no rain, actually for cars passing the tunnel, when there's storm, they close it. Because for public transport, and used for storm water. And I guess Happy Valley would be a nice place. And also, across all the Big Bay area, again, say Shenzhen, there's again shortage of land. Applying the region. Maybe you guys share with them, encouragement use underground car park as well as for water storage.
Yes, actually the co-use concept is what we propose. But each city has its own characteristic. You know, in Hong Kong, co-use for the underground stormwater storage tank or the drainage tunnel may have some difficulty in the sense that, you know, our raining pattern is quite different. We rain from April to October, what we call the wet season. But sometimes in March we also have heavy rainfall. Everybody remember in 2014 in the Kowloon Town Festival Walk shopping mall, it's just March. We have a bad rainstorm. All the shopping mall, just like the how to say? Okay, just like some water goes through the whole shopping center. It's just like a fountain, right? And so if we are going to co-use the stormwater tank, of course initially we need to have good ventilation. Okay, we have to spend something more to ensure the air quality inside is good for people's health. And we need to build some more ramps for the vehicles to go down. We have to build install more lightings. But we need to ask ourselves, when can it serve? If over the whole year we can only use it for 2 or 3 months, then it may not be very effective. Because during rainy season we cannot use it for parking. We need it for fast storage. Okay, so it's maybe some difference. But of course, we are also exploring co-use concept. Your idea is good. So say in the winter time, say if we have 3 months, what can we do for the stormwater storage tank? What other function can we use? Just like this year earlier, some people doing some art performance in our stormwater tank, not in Happy Valley, but in Mongkok, in the Dai Han Dong stormwater storage tank. They perform an art show for in January for about 30 days. This is a very the first attempt in Hong Kong for such co-use with the arts people. Yes, so we can explore more on this, on the co-use concept. And our Drainage Services Department, I can say our top management are open, really very open-minded. Yes.
Bring back to stormwater problem. So my question goes to Ruben again. So what are the differences about DSD's strategy toward frequent storms and very extreme storms?
Frequent storm and
very extreme storms.
Extreme storm. Actually, the rain in Hong Kong, it comes very fast and it comes very heavily. Okay, and in terms of rain, actually we are designing for extreme stormwater. Really. So that's why you can see our drainage tunnel. They are very big in size. 7.25 meter is really very large. We are building for the standard of up to 200 years design return period, and also under such a high intensity. Both are high. Intensity and return period both are high for Hong Kong in the stormwater aspect. But as we just mentioned about the sea level, we are reviewing how we can do better. Because sea level is a little bit complicated. Drainage system is not just one thing. We need to consider the sea level, the storm surge more holistically. Say if it rise 5 meters, the whole coastal area will be affected. Not only the drainage, but also the highways, buildings, everything will be destroyed, will be damaged. Okay, so we cannot just think about stormwater system for this issue. We need to think in a more holistical manner in all infrastructure, everything all together to tackle the sea level rise and stormwater storm surge effects. Yes. Can I answer your question?
Yeah, almost. But may I just add a little bit? When an engineer considered earthquake-resistant design, so was something a small earthquake, okay. Strong earthquake, at least repairable. Huge earthquake, not collapse, but allow problems. Right. So, does DSD promise to the public under certain storms will be fine? Something like that.
We can say we have a certain design standard, and that standard is
performance expectations.
Yes. So it really depends on the rainstorm event, whether it really exceeds our presumed rainfall design standard or not. Sometimes, because nowadays the weather seems to be more extreme and extreme. Even say if Hong Kong Island, we have very heavy rainstorm, but in the new territories, sometimes we still have sunshine. Just in such localized area, Hong Kong is very small, but we do have some different regional rainfall. So it really say if we can check the rainfall data to see whether it exceeds our design standard or anything else. Say if something, say the fallen trees or the tree branches block the inlet of our system, then this is other issue that may cause blockage or flooding to the localized area. So this is we need some investigation in case of flooding. So it's hard to say we can guarantee something or not, but what we have done is really we have built quite substantial drainage assets in Hong Kong, which is at very, very high standard. Okay.
I do have one question to both engineers. So you did show very good examples of some fascinating solutions to landslide and flooding. So my question is, have you done enough for the future climate change, or are there any major challenges to further prepare this kind of climate change from different perspectives, technically, politically, socially? Could you share with us what sort of challenges nowadays?
Yes. Perhaps I respond first. Yes, Anthony, you are quite right. As what I mentioned in my talk, engineering solutions may not solve every problem. We have residual risk, we understand that, because we have uncertainties in our design models, we have assumptions in our design of engineering measures. Nobody can tell that, well, it can withstand, well, all sorts of crisis situations, especially under the challenge of climate change. And therefore, well, community resilience and the use of latest technology, say the sensor technology, the mobile technology, and things like that, in order to enhance our preparedness. Like what I share with you, for example, the smart barrier concept. We try to use those sensors to help us to speed up our emergency response. This is the first step. And when this kind of technology or development become mature, we need to have another phase of the community resilience procedures. For example, emergency drill. That is, when we receive alert from the system, how can we communicate with the people affected? How can we tell them, well, they should evacuate and things like that? So we are heading in this direction. And the soft solution, not the hard solution that I mentioned, the engineering solutions, well, is certainly needed in order to manage the residual risk.
Yes, your question is, are we doing enough? I think things are never enough. Okay, just like money, we are not always enough. So how to do is we regularly carry out the drainage master plan studies. Since 1990s, we carry out a series of drainage master plan studies for almost 20 years, from district to district, from Hong Kong Island to Kowloon and New Territories. And now we are reviewing the drainage master plan studies to incorporate the latest development of Hong Kong. We have more new development areas. These are changes. To incorporate the climate change, say we have more heavy rainfall. So we need to review it to see whether our system is robust enough or resilient enough. If no, the drainage master plan studies will tell us that we need to do something. And then with this regular review, from time to time, we will know what is our deficiencies and what we need to do and plan ahead to safeguard our public. Thank you.
So what about in overseas gas? Is there any challenges in your country when you're implementing adaptation system, the UK specifically maybe?
I guess, and you put me on the spot now, but building on what we were talking about earlier, I think one is deciding what the priority is and who's in the
talk about private development, the property developers, things like that. Well, if they build things, they got to be under the control of buildings ordinance. And I'm not from the buildings department, but I understand that they have regularly, they carry out regular review of, for example, design wind speed and things like that, in order to, incorporate the changes of the climate, things like that. And yes, they're doing in this way.
And actually, I can supplement that for the buildings ordinance, it is actually a law under Hong Kong, Chapter 123. Okay, and they all set the regulations on how to say how the buildings can resist the wind. How shall they provide the drainage, water facilities, the slope, the standards. Okay, all these things are spelled out in the regulations. So this is a matter of law of enforcement. Whenever there is new building developments in Hong Kong, the authorized person, the developer need to employ the authorized person to submit the building plans. Of course, together with some calculations and drawings to the buildings department to approve the building plans before they can build anything. And I will say buildings department is also one of the departments in the climate change working group on infrastructure. So they will know what the climate change impact is, and whether they need to review the ordinance to make some legislative amendments to their buildings ordinance and the subsidiary regulations, that they will have full awareness of this. So, but we are now reviewing all these data and the extreme events last year and this year. The first thing to do is to understand what will be the new data set or the new standard. And then after we have, in particular, the Hong Kong Observatory, some scientific analysis been done, then I think we all, as our West Department or the building authority, they will know how to set the standard. Okay, for infrastructure, no need for enforcement because the government do it. Okay, but for private development, as you correctly point out, it can be done by legislative amendment through the law enforcement. Thank you.
I have actually 2 questions, maybe first for you. So, so is your drainage system a combined like sewer overflow system, combined like rainwater and sewer? Is it combined or like separated?
In Hong Kong, we have separate system. We have drainage pipes for the stormwater. We have separate sewer pipes for the domestic or the municipal sewage.
Oh.
It's a separate system.
And do you have any treatment plan for the
the the sewage treatment is also done by our drainage service department, by the government, not by the private developer. Yes.
But any treatment plant, or do you treat this overflow?
Normally, we connect all the sewage. Okay, say in your building, your toilet, your kitchen, all the sewage will go underground to our sewage system network, and then finally to our sewage treatment work. We have over 70 sewage treatment works in Hong Kong, 70 numbers of plants. So we treat it, and then before we discharge it to the sea. Yes, we treat it to some primary level and some secondary treatment level to remove the pollutants, to remove the sediments, and to make it clean. And for some very water-sensitive zone, we also have ultraviolence to disinfect the water before we discharge to the sea. Yeah, we have a very high wastewater treatment standard in Hong Kong. Because Hong Kong is so dense, and we cannot afford to pollute our harbor or the river because health, sanitary is really a 100 years ago, we don't have a very comprehensive sewage system and sewage treatment system. And that's why sometimes a lot of health problems occurred and many people died. This 100 something years ago. We now have a very good sewage treatment system.
And when you think about climate change, have you thought about like, why you actually updating this treatment plans, or no, this is not an issue. About in terms of capacity.
So for sewage treatment, will we go too far? I can mention very shortly. Okay, we also do some review on how climate change will affect our sewage treatment process and how it will affect our sewage system and our sewage treatment work. We are now carrying out some studies together with the universities. You know, sewage treatment basically say climate change effect is relatively gradual. Say the temperature increase, okay, maybe 1 to 2 degrees over a certain period of time. That may not have very distinct or quick impact to us as storm surge. You know, storm surges are very quick and imminent. But sewage treatment, relatively, climate change effect is relatively gradual. And of course, we still need to tackle them. But so that's why we are carrying out some studies.
Maybe the last one is just a kind of comment, but maybe if you have some ideas, especially for mainland China. One of the problems we face about the drainage system is like the revenue of the system. When you look at like water supply, water treatment, waste treatment, solid waste treatment, I mean people pay for this service. We have like also private companies, because if you don't pay, you don't get water and so on. But for the drainage system, especially for the poor municipalities, for the poor counties, people cannot afford to pay, and it's hard for the municipalities. I mean to generate some revenue and invest in some infrastructure, drainage system. So I was wondering if, especially if you face the same problems, maybe in mainland China, like, because I mean, if you don't get any revenue, how you can invest in some infrastructure? I was wondering if you have any comment or some ideas.
So this is a different policy in Hong Kong. Say our slopes, even they don't generate revenue. The drainage stormwater system, yes, they don't generate. But we all work under the Hong Kong government, and we have reserve money for the operation and maintenance every year. We also reserve under the capital land reserve fund. We have money to build some new infrastructure, to upgrade the standard, to do some improvement work. This is Hong Kong. We do it like this. We are not collecting because we are not self-financing. We are under the whole financial portfolio, and every year we have a budget. Okay, we have some resource allocation exercise to the whole government internally will deploy some money to different departments for their proper carrying out of their functions.
So
we will not ban transfer.
But same thing for mainland China. It works the same way when you have like very small cities. So it's not self-funded, the system. You don't have any revenue. So where does the money come from? It's like from the federal government or the state, or how does it? Do you have how does it work?
We don't know.
Because we have like the low level is like counties, and then the state level and the federal level, and the lower level, like the municipality, is responsible for the system. That's one big problem.
We have speakers from China for other workshop, so probably during the dinner you can chat with Chinese speakers.
Yeah. So
thank you for participating in this workshop. It has been very successful, I think, and we generate some good ideas. And may I invite you to join me to thank our speakers for their excellent Thank you very much. So, dinner time. So, could you check your name badge? If you have a sign of that red dot, you can have a gala dinner with us. I apologize for those who don't have it because of the limit of size. So for those who will join the dinner, please wait outside the big red bird of the HKUSD icon, what we call it red bird. Yeah, you know that.